All right, good morning. So time to resume our learning about object equality. So let's now, before we do that, let's now do the routine. Let's now remind you about what's going to happen in the course. We got 6 more weeks to come. Okay, still quite a bit to cover. So your programming test 1 result, I'll make sure I return by next Monday. If I can make it happen earlier, I'll definitely do that. But we're still finalizing the results. And for your lab number 2, just don't forget, it's due this Friday. If you have finished that already, just submit and claim your credits. And don't forget, I already released the solution video and also the grading test for you. So please take a look. Lab 2 is so relevant to your upcoming programming test number 2, which will be the next assessment. Let's now take a look at the calendar together just to see where we are in the course very quickly. So you go to make sure you refresh your browser because I updated slightly on the release date and due dates for the labs, right? Like what I announced during the reading week. We are now here today for lecture number 12. My plan is to finish hopefully most of the object equality today, and then for Thursday and hopefully a very small part of next Tuesday, I'm going to finish something called aggregation and composition. That's something I will do, hopefully only until the very early part of next Tuesday. And then for the upcoming 6 lectures at least, we're going to talk about inheritance. That's something I keep emphasizing. That's going to be the goal for this course. All right? And then for later today or early tomorrow, I'm going to give you guys some design challenge, which is going to be so relevant to the running example that we're going to do for the inheritance lecture, right? So that's something I will encourage you to really try it out and have some thoughts to it. So when we introduce inheritance, you will so much appreciate what is so nice about inheritance, right? I'll reach out to you. And of course, you guys have to really get prepared for programming test number 2. It will be next Wednesday. So for this coming Wednesday, tomorrow, you can still drop by the scheduled lab session to talk to the TA if you still need some help on lab number 2. But if you just want to follow through the tutorial video with me and then work out your solution, you can do that too. And don't forget, I got office hour today and also Thursday, as usual. If you want extra time, reach out to me. I'll be happy to make some time for you. And then that's about it. And you can also expect lab number 3 to be released this coming Friday. But lab number 3 is going to be a relatively simpler lab, like a smaller lab to be done. So given that you have been struggling through and learning a lot from lab number 1 and 2, number 3 should be quite straightforward. And lab number 4 and 5 will be a little bit more challenging again, but that one's really going to push you to learn about inheritance, right? Well, we can look forward to that. Right, but I guess the exam schedule will be officially announced pretty soon. And then once we know that, we'll see how we can plan, maybe for some extra review session for you to get prepared for the exam. So guys, any questions about the course before we get started again? Alrighty. And let's now just make sure you brush up on what we spoke about before the reading week, right? I think it is important for us to know where we are and how we're going to continue for today. All right, so before the reading week, we introduced you about the idea of the equals method. Especially, we talk about the object class, which has the default version of the equals accessor, which takes some objects and you're going to return a Boolean. By default, it's simply just going to do the so-called reference comparison, which is simply going to use the equals, which will compare the references of the current objects and also the parameter over here, right? That's something we spoke about thoroughly before the reading week. And in this case, point V1, it does not have any overridden version of the equals method. That's why when you try to call the equals method on P1 of type point V1, in that way, it's simply going to invoke the default version that's inherited to point V1, right? And the more complicated version will come to us if you have a class, for example, point V2, in which case you do decide to explicitly override the equals method. In that way, for example, if you say something like, let's say P2 dot equals P3, for example, where P2 over here is of type point V2. In that way, which version of the equals method are we going to call? It's going to call the version that sits in point V2. You don't really go to the default version anymore because you got something already in point V2. Right? That's a critical difference you want to see. And one more thing to say, before the reading week, we actually spoke about 1, 2, and 3. Right? So these are the 3 lines that we spoke about also thoroughly before the reading week. So I'm going to assume you guys are okay with it. If you're not, please catch up and reach out to me. Today, we're going to continue from over here, the last part over here. But to really get you guys ready for this particular part, we did some exercise, right? If you remember. That's also something kind of remind you yesterday. Let's take a look at the exercise here. So the exercise here really illustrated the basic use of something called static type, dynamic type, and also typecasting. That's something I might just briefly review very quickly today when we talk about the last bit for the equals method. But very quick. Static type simply means whatever type you declare the variable to be. For example, for O1, the static type will be just C1. And it never changes. So static type itself is very, very straightforward. It never changes once you declare it. And what is so special about static type? Static type for the variable is going to determine the range of methods you can actually call on the context objects. For example, let's say over here, if you got O1 over here, O1 static type is C1. And the only method you can call on C1 would be just M1. So that's why when you say O1.M2, M2 does not belong to C1. It actually belongs to C2. So that's why it wouldn't compile. Right? That's something we said before the reading week. And dynamic type over here is really about the type of objects that's being pointed to by the reference. That could be C1 or it could be C2. And it might change. For example, let's say O3 over here. When we first do, O3 is assigned to O1. So in that way, O3 is pointing to wherever O1 is pointing to. So dynamically, O3 is of type C1. And we cannot actually invoke O3.M1, even though O3 is really pointing to C1 objects, simply because O3 has a static type objects. The object class does not declare M1. M1 is only declared in C1. So in this case, if you're so sure that O3 is really pointing to some C1 objects, you can do something called typecasting. Right? And once you have done the typecasting, you can actually call the method accordingly. Right? So everything I have reviewed so far is something we talked about before the reading week. So if you still have doubts, catch up. All right? This is so important. And once we go to the inheritance lecture from next week, we also got to revisit this with even more depth. So I think that this will be the best preview for you. Yes?
What if we declare one of the methods as static?
What if declare one of the methods is static? I would say let's not add a complication for now. I think for most of the parts that we're going to talk about for the course, we only consider static variables. So whenever you declare something like a static method, you will say the class name, that method. I would say the principle wouldn't really change, but let's not add a complication. Yeah. So for now, we only consider static variables, like what we review in the OOP lecture. But whenever we talk about method call, unless I mention explicitly, we always do non-static methods, like a normal, without the static keyword. It will be just easier for the discussion. Yeah. All right, guys, anything else? Yes? Okay, good. Let me review that as well. So another thing that I think that you guys should also recall is when we look at here, okay, it should be phase number 3. There we go. So phase number 3 is really about this guy here. So there is a class, there's a method there that's supported by Java. You don't declare yourself, it's already there. So the get class is going to return the dynamic type, meaning that, for example, let's say right now, let's say if this is pointing to an object that's of type triangle, in that way, dynamic type will be triangle. But later on, if you change this to be something with dynamic type star, then get class is going to give you star instead. Right? We'll see that again. All right. Alrighty. So if no further question, let's now move on. All right. So what we'd like to do is to continue, and given that we know about static type, dynamic type, and typecasting, the last bit over here will be pretty straightforward. But let's now just revisit all the ideas once more, just to be sure. What I would like to start with is by looking at the parameter. If you look at this line here, you can see we got some parameter obj, and then the object over here is so-called a static type for obj. So this is the static type of obj. What does that mean? That means you can only invoke methods on obj that's defined in the object class. Can invoke on obj only methods from the object class, simply because the object class is the static type for obj, as you can see, right? They're all relevant. Are we okay so far, right? We're really reviewing the concept over here. I would say this is the most important detail you want to notice. Let me repeat again, all right? It is so important. The default version of the equals method from the object class declare the parameter of type objects. That tells you whenever you want to invoke any methods on obj, you have to be restricted by the static type, which is objects. In the object class, we don't really have, for example, the attributes like x and y. So if you want to invoke x and y on obj directly, no, it wouldn't compile. What we can do is we can do some typecasting. If we are so sure that obj dynamically is really pointing to some objects dynamically of type point v2, for example. Right? That's something we'll see. All right, so for these three lines, I'm going to skip them. So these are the ones that we spoke about before the reading week, so we don't need to spend more time. But let's now talk about these quickly. Okay? If we are able to reach this line over here, there are several things we know. You can use this like a review question for you guys. Number one, we know that this is not equal to obj. They are not the same objects. Otherwise, we would have just returned true. All right? Number two, we know that obj is not equal to null. Otherwise, we would have just returned false over here. Right? Number three, we know that this and obj have the same dynamic type. Because over here we say that if they do not have the same dynamic type, we would have returned false already. If we are able to reach this line, that means their dynamic type must be the same. Right? It's a very important, there are three very important properties for you to really convince yourself, right? If we are able to reach the purple line, that means all the above three if branches have evaluated to false. So we didn't return anything just yet. Right? Logically, that makes sense. Let's now take a look at this guy here. All right? Hypothetically, how about this? I'll write it down aside so it'll be very clear to you. Let's say I put a star here. Let's say without this line of typecasting. If without this typecasting, can we write the following? When we say return, and we'll simply say this dot x equals. So rather than using other, which is basically like a typecasting product, right? Let's say we don't use that. Let me do something instead. Equals, let's say obj. And also this dot y equals obj dot y. What happened to this alternative implementation there? Any clue? If I write this line instead, is it going to work? Well, to be honest, if this line worked, then we didn't even need a typecast in the first place, right? So that's why I want to explicitly write it out to you. This line here is not going to compile even because, can anybody explain to me? Why would this line not compile? Go ahead, yeah. Yeah, in this case, X and Y, right? Exactly. All right. Let's now be very clear and write it down, right? So guys, that's really something you want to be very used to. And we're going to play a lot with static type and dynamic type once we get to inheritance. It is so important, right? So if you think about OBJ over here and also OBJ over here, so we know that the static type is objects. Exactly over here. So that means X and Y are not applicable. We are basically working like a compiler. I'm telling you exactly the logic for the compiler. Okay? Right, so this isn't going to work. So what we do instead is like this. So at the runtime, this is what's happening. Okay? Let's now try to visualize what's happening here. So based on property number 3, so we got this, the current objects is pointing to some point v2 objects, right? So it's point v2. And we know that they have the same dynamic type. So OBJ is also pointing to another object of the same dynamic type. The contents might be different, but at least we know dynamically they are the same. This is also point v2. Right? If you look at that, dynamically they are the same. This and OBJ. However, statically for OBJ, the static type is actually objects. So you cannot do obj.x. You can also not do obj.y either. So what we do instead is to say, can we simply create an alias? So we don't really want to create any objects, like a new object to waste the memory. We just want to create an alias pointing to the same objects as OBJ, but this alias here is going to have the correct static type for us to call X and Y. All right? So that's exactly what this line is doing. All right? So let's now take a look at this line here. If you look at this line here, now let's look at the right-hand side. We're going to cast OBJ into point v2. We can do this because OBJ dynamically is really pointing to some point v2 object. So it is okay to cast that into something just the same. Okay? So what we do is we're going to create some alias over here. And that alias has the static type point v2. Point v2. And then we're going to assign that alias to another name variable called other. So you can think about other is actually going to be here. And other also has the correct static type. And apparently this is a typo here. This one should be point v2. All right? I'm going to fix that. Maybe on the slides. So this one should be point v2. All right? And once we have done this line here, what we can do is we simply say, now in order for the 2 points to be equal, this dot x should be equal to other.x. So now we will be able to call other.x simply because other has a static type point v2. Are we okay with this? Okay. Let me just do one more annotation and then I can take your question. Other.y over here, for example, is going to compile because the static type of other is point v2. Okay. All right, any question so far? it is okay to say you're completely lost. That's okay. So I can repeat again. I'd rather you say that now. Okay, completely lost? Okay, no problem. Okay, I'll take question here. Yeah?
So I just want some clarification on when you typecast it, what happens to that object class?
So, okay, how about this? Let me repeat again, maybe the overall picture. Maybe that'll be a little bit better. For the details, you can still watch the recording. Okay, let me start from the beginning. It is important, so it's worth our time. We are trying to define this equals method. It is important to notice that the OBJ, the parameter, has static type objects, meaning that whenever you want to invoke something like obj.x, obj.y, it's not going to work because the static type object here does not declare x and y. X and y is only declared at this level here, point v2. That's one thing you should really understand right away. Okay? And then when we get to this point over here, right, we know that visually this is pointing to some point v2 objects. OBJ is also pointing to some point v2 objects. The difference is now this is really inside the point v2 class. So you're okay to call x and y because statically it is just point v2. However, for OBJ over here, that one has the object as a static type, so you cannot do it. But we are so sure this dynamic type is really point v2, we should be able to call x and y. The only way to trick the compiler or to convince the compiler is to say, rather than using OBJ to call, we're going to create some alias over here, and that alias is really pointing to the same object. The object itself doesn't change. We're just using a different name to call that. And the reason that this can convince the compiler is because this variable here, other, is declared to be of static type point v2 as opposed to objects. So that's a critical bit we're doing. All right? So two things. Number one, from the parameter declaration of OBJ, we cannot call obj.x, obj.y. But you can do it by casting it into the point v2 class that we are talking about. So that's why when you say other.x, other.y, this will be fine. Because other has a static type point v2, which does declare x and y. Better? Okay.
Does that mean the memory will delete the object? OBJ?
No. Okay, maybe also corresponding to Robert's question. So here, for the point v2 object that's being pointed to by OBJ, that one doesn't change anything. Doesn't change. So object remains intact, remains untouched. The only thing we did is to create another variable storing the address of the same object. That's all we do. But somehow we are able to use this variable here to call x and y because that variable was declared with a different static type. That's why. But you just cannot use OBJ. Yeah. So have we wasted any memory? A bit, just by declaring a new variable. That's it. That's okay. That's something we can afford. All right, guys, any other question? Think about this. I think this might be a little bit trickier. So that's why I wanted to do that example about static type, dynamic type with you first so you get a feel. But this one here, really understand what we're doing here because you're going to need that for your lab number 3. Okay? You will need that. Robert.
So my question wasn't really regarding that, but it was more of like the actual how the object class works in Java. Because you said every object is a subclass of the object.
Yes.
So you pass the object, but the thing that was passed, was that created as an object? Or was it like...
I think maybe, okay, how about this? I would say hold this question here. You are more asking about how does the parameter and argument somehow work together. That one is something called call by value, which will be right after the object equality lecture. Most likely we'll talk about it on Thursday. How about just wait for that? That'll be much clearer. Okay? All right, any other follow-up? All right, if you're still struggling, please keep struggling, but you got to reach out at some point. Right? It is important. Either you clarify now or you clarify in the test. Right? You definitely want to do it now. All right. Spend more time. Spend more time thinking about this. All right. So let's now do some example quickly. All right. Let's now try to trace the code. So I'm going to trace this line only. All right. But before that, let's remind ourselves about the object structure. So here we only care about P1 and P2. All right. So P1 and P2 over here, so these are the two relevant objects that we need to look at. So P1 will be 2, 3. P2 will be also 2 and 3. They are different objects. Okay. Now, let's now try to invoke P1 dot equals P2. So P1 dot equals P2. I'm talking about line number 10. Okay. How do we know which version of the equals method should be invoked? It depends on the dynamic type of the context objects. So this is the context objects. Its dynamic type is, because P1 is currently pointing to some point V2 objects, so dynamic type should be point V2. So we know that we have to go to point V2 class and see if there's any equals method there overridden. Indeed, there is. So this will be the method to be called. That's something you want to see right away. All right. And how do we invoke this? P1 dot equals P2. So that means every occurrence of OBJ should be replaced by P2, which is the arguments. So OBJ over here should be replaced by P2. And also OBJ here should be replaced by P2. And also that'll be it. All right? And it would be an exercise for you to really trace the codes to convince you every one of the 3 branches over here is going to evaluate to false. So don't return anything earlier, right? Exercise to trace. All right? And we should be able to reach to this point here. And what does it do? It is going to say P2 is currently, yes. So P2 is actually pointing to this object over here, right? At the same time, we also got OBJ. Let me put it this way. So here, look at this line here first, number 1. Number 1 here, we're doing a typecasting, meaning that we're creating an alias to wherever P2 is pointing to. All right? And then we are casting that into point V2 type. Okay? So that means this particular alias over here is of type point V2. So this will allow us to say that alias.x and also .y. And we're going to give it a name called other. All right, so it's going to be called just other over here. So this is the consequence of doing that typecasting. All right? And once I've done this, it will be very straightforward. We're simply going to return the following Boolean expression. So this, by the way, the context object should be just P1. P1. So we are saying that P1.x equals P2.y, which P1.x over here, other.x, what about other? Other.x will be here, P1.x will be here. So 2 and 2, so they are the same. And also P1.y here, other.y will be over here, 3 and 3. So that's good. All right, that's how things happen at the runtime. Of course, I think the most important thing is at the compilation time to really understand why we need the typecasting. But once you get to the runtime, you just have to remember whenever you see any typecasting like this, you're basically just creating an object alias like this. So let me just do that one here. So you should really understand this one here is really corresponding to the alias we're creating. And we call that other over here. Okay? Question? Yeah. You're passing P2 as argument here? Yes. Okay, I see where you're going. I would say let's not worry about it because that one also has to do with call by value. I would say for now, let's just understand the following. Because I know that I got P2 as the arguments, so somehow conceptually I can replace every occurrence of OBJ just by P2 for now. But once we talk about the call by value, maybe on Thursday, you can try to fill the gap to fill a little bit more detail. For now, let's not confuse ourselves further. Okay. Yeah. All right, any question? We okay? Okay, let's now move on. But we're going to do also more tracing today. Okay, let's do another one quickly. Okay. So now, what about P? So we used to do P1 dot equals P2. What about P2 dot equals P3? Okay, so now the relevant objects are P2 and P3. You'll be traced in a very similar way. So P2 and P3 are the two objects here. So we got P2, P3. So 2, 3, and also 4, 6. And the line we are tracing is this one over here, right? So when you do P2 dot equals P3, all right? Again, which version should we call? It's a different context object now. So the context object has the dynamic type because P2 is pointing to some point V2 objects. So it should be point V2. And we're going to execute a version of the equals method in point V2, the same. All right? And then, again, it will be exercise for you to really trace up to here, but let's do it from here. All right? What we're doing is every occurrence of obj, the argument should be replaced by P3 here. Obj, P3, obj, P3. And if you look at this line over here, again, we are creating some alias. So we are basically creating an alias pointing to just the same object as P3. So this will be other. And this one here has the static type corresponding to what we are casting that into, which is point V2. Right? Of course, we're calling that other. Okay? That's what we have. And once we have done that, we can now try to return this expression here as the return value. Let's try that. And don't forget, so this is really P2, right? So this will be P2. And also other dot x, other dot y. Let's try that. P2 dot x, other dot x, P2 dot x, other dot x, 2 and 4. You can see they are not the same right away. The contents are different. So that's why this one here is going to give you false. All right. So now this will conclude about the definition for equals method. But we're going to do more exercises to reinforce your understanding. Before that, is there any question about what we have done so far? We're good? Okay. So maybe for your written test number 2, not so soon, but at some point this term, we're going to do something like this in the test. So you really want to make sure you understand how to trace the different version for the equals method and also how the typecasting can be visualized. That's something you definitely want to get prepared for the test. It's an important understanding to know. Okay, so if you go back to slide number 9, that one basically summarizes what we just have seen. Right? I'll let you read it, just consistent with what I said in the notes. You can read the slides. And then let's now talk about equality. So there are two notions of equality there. Before that, let me just do one more summarizing example. So this page over here, I'll try to keep it as clean as possible. It kind of summarizes what we have done so far. We have the superclass over there called objects, which has the default version of equals. And for point V1, that does not override the equals method, we're just going to use this default version. But for point V2, that actually has explicitly overridden the equals method, in that way, we're going to use this version instead, if the context object has that dynamic type. And now I kind of put all the exercises we have done so far into these two blocks. Right? You want to review them and make sure you're convinced about the answer. But I want to draw your specific attention to line number 10 and also line number 10 over here. The reason is because if you compare these two fragments here, this is the only line where you got different answer between the two equals method. One is going to give you false, the other one is going to give you true. All right? I'm just doing the comparison for you. But why is that? Let's take a look very quickly. If you look at that here, let's look at the context objects. You can see for P1 over here, dynamically, it is pointing to some point V1 objects. So this is the dynamic type, meaning that we're going to go for the version of equals method in point V1. But for that one there, we're going to go for this one here. That one there is simply just going to compare references. Now, in this case, if you try to compare references between P1 and P2, of course, they are different objects. All right? That's the first one. What about the next one, line number 10 here? Here we got P1 over here, and P1 dynamically is of type point V2. So now, which version of equals method are we going to call? We're going to go to the dynamic type, which is point V2. And that one there has some overridden method equals here. So we're going to call this version. And that one there is going to do everything we have said so far. You can do the tracing. And if you compare P1 and P2, 2, 3, and 2, 3. Contents are the same, even though they are different objects. So that's why it's going to be true. So this one really tells you if you have only the default equals, in that way, you may not be flexible enough. Even though the two objects have the same contents, but since they are different addresses, you might just return false using the default equals. But if the two objects are of the same contents, but you also got the equals method overridden accordingly, you will be able to return true. Right? That's really the essence for the comparison. I'll leave the page pretty clean, and then you can think about it. Yes?
What is the cases that it's better to override?
It's a good question. The question was, when should you override, when should you not to override? I would say in most cases, you have to override. Most cases. And to be very fair, even in the overridden version here, we already consider if this equals object, we're going to return true anyway. Right? So we're just saying that if the two objects are just different addresses, we want to go further to see if their contents are the same. So I would say the overridden version is almost always just a better version. Yes. Mm-hmm. Before we didn't do it in lab 0 and lab 1 simply because we haven't covered that yet. So it's good to now know. Most of the time, you want to override the equals. Most of the time. All right, so think about that comparison. And let's now talk about something also important, right? Now we're going to put things together. There's a notion about reference equality, meaning that the two objects have the same address. Also the notion about object equality. Object equality simply means depending on how you have overridden your equals method, if that return true on the two objects, we say that those two objects are object equal. But now we want to think about how these two may be understood. Somehow we can put it in a logical relation. Before that, question?
Sorry, quick question about the previous slide. So the overridden equals method will compare the context of the object despite the address of the object being different?
That's correct. So the question was about the overridden method here. You can see that if you actually somehow evaluate this guy here to be false. So this false means they are not equal to. That means the references are different. So they are not the same object. However, we still go on to say maybe their contents are the same. In that case, we still get a chance to return true. It's a good question. Good. All right, anything else before I move on? Guys, always interrupt me and let me go back. That's okay. I'd rather you understand it. All right, if that's good, let's now move on. Okay, let's now talk about equality here. Let me see if there's anything else I want to say on the slide. So we got reference equality, which will use equal to compare addresses. And also we got object equality, which will use the equals method. And of course, the equals method itself really depends on how you define that, how you override it. It really depends. All right, so what I want you guys to think about is this. I got another piece of code here for your example, but I'm only going to show part of it just to make my point. Now, I want to ask you this one to think about right away. You guys took like a logic course before, right? Like an implication. You know implication? All right. If I remind you, I say something like a P implies Q. I know some of you may have learned it like a P implies Q. Doesn't matter. Okay, I'm talking about implication. Let's say this. Imagine that this is one proposition. I say two objects are reference equal. What I meant was, for A, I really meant P equals Q. Oh, sorry, maybe I can use a different object. Let's say obj1 equals obj2. That's what A was talking about, the same reference. And for B, two objects are contents equal. That means I say something like obj1 dot equals, I'll just say EQ, so you know what I meant, obj2. This is a proposition because it's going to tell you either true or false. This one here is also a proposition, which is also going to tell you true or false. Right? So now we want to see whether there's a logical relation between them. Now let's read it, and you tell me A or B. You tell me 1 or 2. So option number 1 tells me that if I know this proposition is true, it's guaranteed this proposition will be true as well. Number 2 is telling me that if I know this proposition is true, I would know this proposition is also true. You can see the reverse, right? Now 1 and 2, let's say it's a multiple choice with boxes. Which one do you think 1 or 2 is true? 1 or 2 or both? You think 1 is true? Okay, 1 is actually quite easy to justify, okay? But it's the boxes, right? We might have multiple correct answers. If we got 1 over here, that simply means, for example, obj1 and obj2, they are really pointing to the same object over here. If they're the same objects, the same object doesn't really matter how you compare the contents. It will just be equal to itself, right? So 1 is definitely correct. What about 2? Do you think 2 is true in general? 2 is saying the following. If I somehow know the two objects have the same contents, can I conclude to say that they are the same objects? They are storing the same location of the memory. Definitely not, right? Okay, let's see. But we have seen this counter example already. All right, so number 2 is not in general true. So I'm going to put a cross over here. And the way to see a counter example would be just over here. So now for this guy here, you can see P1 and P2, since they're creating separately, so P1 and P2 definitely is false. Right? And then P1 dot equals P2. We are talking about point V2, so we're going to use the overridden version. And now, are they of the same contents, 3 and 4? Indeed. So that's why P1 dot equals P2 will be true. And now if we apply this over here, so B is about object equality, which is true. And A is about reference equality, which is false. And I'm pretty sure you guys know about the truth table for implies. And this guy here will just give you false. So this is not true in general. All right? But don't worry, I'm not going to ask you about truth table in the exam. But it's good to know. Okay? All right, so that's something you want to really keep in mind. So reference equality is a much stronger logically statement to make. If you say the two objects are simply stored in the same address in the memory, of course they are object equal, but not vice versa. Okay, that's the main point I want to make. And then, yeah, you can look at other parts for the printout. You can just as exercise. All right, so this is actually from the Java API, the object class. This is to say if you want to design your own equals method, let's say your lab number 3, it's always good to have some checks whether you have done this. For example, you want to make sure if you got x dot equals null, this, oh, by the way, this is logical negation. Okay, what that means is, okay, this one may be a little bit trickier. Okay. I'll put it here. So when you see that not the case, x dot equals null. This one tells you x dot equals null should always return false, which indeed is already covered in the overridden version, right? But let's see why. The logic is very simple. Let's say if you want to return true over here, what does that mean? That means both x and null are the same. Can x be null? No, you'll get null pointer exception, right? Even before you get to execute the equals method. All right? All right. Return true means x equals null, which doesn't make sense. Null pointer exception would have already occurred. All right, that's something maybe worth noting a bit. All right, and then we got another one. So x should be equal to itself, right? And also, if you say x equals y, y should be equal to x, right? Symmetric. And also, if you say x equal y, y equal to z, x must equal to z. Right, so these are the things you want to think about when you design your equals method, right? That's from the Java API, so I want to mention that. That could be a checklist for you. Okay, let's now talk a little bit about JUnit test, just a bit, and then we can take a short break, just a little bit more. And I'm going to go back to, that slide will be okay. So there are two things let's talk about first. Assert same and assert equals, okay? Let me move on directly to the page over here. So there is a JUnit test assertion called assert the same, which I haven't really used so far, I guess, in the lab. But since now you're going to learn it, so I can use it, right? What does really assert really mean, assert same? Just always remember, whenever you say assert the same, expression 1, expression 2, you're basically saying the two expressions are just equal to each other using equal. In the case of the reference variables, you're just comparing the references. Simple definition. So you just want to remember when I say assert the same over here really is denoting the equals operator. All right? So you can think about, if I say assert the same, expression 1, expression 2, if that one pass, what does that mean? That means expression 1 and also expression 2, they point to just the same objects. There will be another two equivalent way to say it. You can say assert true, expression 1, expression 2. Right? This one is a little bit trickier. I can say expression 1 not equal to expression 2. That should be false because they are indeed the same objects. In that way, you assert false, which is going to pass. Right? A little bit trickier, but it's not too bad. So assert same is very straightforward. Okay, let's now give a try. So we got P1, P2, and P3. So now we're only worrying about the references. So P1 is a new object. P2 is just another new object here. And you got P3 is pointing to wherever P1 is pointing to. Right? So now we can do assertion check right away. Assert the same, P1, P3. So now, you may not want to say true or false. It should be pass or fail because we're doing assertion. P1, P3 should be passing. And what about P2, P3? Should be failing because they are of different objects. Okay, that's what I want to say about assert the same. Okay, pretty straightforward. And let's talk about equals. And we need to talk about different cases. So for case number 1, whenever you say assert equals over here, and you got expression 1, expression 2, if these two expressions happen to be primitive types, for example, integer, Boolean, in that way, it will be as if we compare their values, equal. So this equal here is not about reference comparison. It's just about comparing the value for primitive type. So that's why I say here, primitive type. And for example, we got I and j, 10 and 20, and then we compare I and j by say assert equals. So this one over here would be as if this one here is just equivalent to assert true, and then we say I equals j. All right? If you want to make it fancy, you can also say assert false, I not equal to j. All right, you can say that too. Okay. Okay, let's now look at a slightly more complicated case. So what we just spoke about is case number 1, basically, about primitive type. Let's say we got reference type, expression 1, expression 2. So now we are making the assumption that these two are reference type. Reference types. All right? And it can be simply boiled down into expression 1, expression 2. All right? So let me just make a very big notes over here. So now when you say assert equals, let's say we got expression 1 and also expression 2. And what we know is these two are both reference type. May not be of the same type. They don't need to be. So this is a reference, let's say reference type. And this is just another reference type. So the whole thing is going to be boiling down into assert true, and then here I'm going to put expression 1 dot equals expression 2. All right, that's something you have to somehow remember. And notice that the expression 1, which is the first argument to assert equals, this will be turned into context objects. Context objects, as you can see, that's exactly the context object over here. And expression 2 over here would be the arguments. You can see that one there is the argument. The order matters. That is to say, if I say assert equals, let me swap the order. Expression 2, expression 1. It's going to be assert true. And then it's going to be expression 1. It's now going to be the argument rather than context objects. Expression 2 dot equals expression 1. Now, why is the order so important over here? If you recall what I said earlier, how do we decide the version of the equals to be invoked? It depends on the dynamic type of the context objects. So now, what about case number 1? Let's say this is 1, this is 2. Because we know that it will boil down into the equals over here, so that means the dynamic type for expression 1 is going to determine the version of the equals we're going to call. If that one is point v1, we call the default version. If that one is point v2, we call the overridden version, right? So expression 1 here, dynamic type determines the version of equals to invoke. All right, and similarly, let's say here, you can see here we got expression 2 come first. So expression 2, right? You can see now the dynamic type for expression 2 is going to determine, not expression 1 in this case, right? So the order does matter. All right, that could be the common confusion. So how you put as the first argument to assert equals it's going to make a difference at the runtime. It's going to impact about which version you're going to check. All right, let's now take a look at maybe some example. Yes, of course. You know, I would say maybe yes, that kind of notion, let me get to that maybe a little bit later, because that one has something to do with something called dynamic binding, which we have to talk about again when we talk about inheritance. So I would say for now, all you got to remember is, if I got, let's say, expression 1.equals versus expression 2.equals. Now the context objects are different. How do you decide which version of the equals method to invoke? You got to look at the type of object that's being dynamically pointed to by expression 1 versus expression 2. That's going to determine which version is going to be called.
So is it not like you look at the static type of the object?
Static type only tells you if you can call the method or not. But the version of the method is going to be determined by dynamic type. Yeah, that's something I will emphasize 100 times when I talk about inheritance, so don't worry. Yeah. All right, so let's now move back and do a little bit example here. All right, so this one will be fun, okay? So let's say we got P1, P2, P3. All right, so now, good. Okay, so here, let's say when we say assert equals P1, comma P2, this one will boil down into P1 dot equals P2. And as you can see, P1 is the context objects, and P1 has the dynamic type point V1. So that one tells you you're going to invoke the default version. Default version of equals. So that means we're just going to compare references between P1 and P2. Now, are they the same objects? Not really. All right, so that's going to be false. That's how you determine the first one. And what about the second one here? The second one here, let's see. Assert equals P2, P3, right? So now this can boil down into P2 dot equals P3. And if you look at this dynamic type, so P2 over here has the dynamic type also point V1. That's okay. And then now you're also going to default version of the equals. So this will boil down into P2 equals P3, right? It's going to be P2 equals P3. However, you can see P2 and P3, they are simply different objects, I agree, but even different dynamic types. There's something I mentioned before the reading week, which I said, now, it will boil down into P2 not equals P3, but put in the quote, meaning that if you try to do this in the assert equals P2 and P3, or try to do equals P2 dot equals P3, that's okay. However, if you try to write down P2 equals P3 directly in Eclipse, it's not going to compile. I show you this on the Eclipse. That's something you want to review as well. All right, so this one is also going to return false. Because P2 and P3, they are simply different objects here. All right, there's something we're really building up on what we talked about before the reading week. Okay? All right, let's now move on. Let me do just one of them. You can do the rest on your own. So let's now try to do, how about this one here? This one will be slightly different. Oh, sorry. What I meant was, how about this one here? The last one. All right, I'll make it a little bit bigger. Okay, this one here. We know that this one is going to boil down into P3 dot equals P2. Now, which version of the equals are we going to invoke? Let's look at the dynamic type. P3 has the dynamic type point V2, as we can see over here. Okay, so this is the dynamic type. So that means we're going to invoke the version of equals in point v2, which is an overridden version. So that means invoke the overridden version. In point v2. And that one there, we know that it's going to compare the contents, which in this case, oh, actually, this one is actually even more interesting. I'm going to put this in exercise, but I'll give you enough hints. If you try to say P3 dot equals P2, right? Now, am I going to return just true, given that we got 3, 4, and also 3, 4? Am I or am I not? Okay, I'll pose a question here, all right? Oh, sorry. Let me make it very clear. I think this is really worth your attention. I'm hoping to get this a little bit better. Okay, one more try. There we go. Okay, this one here. I'll put a star here. Given that, so we talk about P2 and P3. Both P2 and P3 actually store 3, 4 and 3, 4. Is P3 dot equals P2 returning true? This is an important question. Now, can anybody tell me if that should be returning true or false?
False, because they're not the same class.
They are not the same dynamic types. All right, guys, hints for you. For those of you who might be wondering, if you got a good intuition to say, now, P2 dynamically is point V1, P3 dynamically is point V2, there is actually a line that's going to make sure we're going to get return false here. This line here. Because when you say that one that get class and that one that get class, they are not going to be equal. Point V1 versus point V2. So that one there is not going to be true. All right, think about it. That's also something we just covered. All right, it should be false. All right.
But if we say that P3 equals P2, we're gonna follow the override method, which is
Yes.
converting P2 into V.
Yes, that's correct. So, yeah, we're not even going to reach that line. So if you try to do P3, okay, I see your question. So in this case, when we say P3 dot equals P2, right? So when we execute it, we are actually going to reach this line over here, and that one is already going to return false here. So we're going to return false. You don't even get a chance to get to this point. So you don't need to worry about it. Yeah. So in some way, this line over here also help us from getting into the embarrassing situation where OBJ is not really pointing to some point V2 objects, but we're still casting it in some way. Okay? Mm-hmm. All right. All right, any question? Yes.
The only difference between assert equals and assert same is that assert equals can be modified.
That's correct. So assert same always boils down into equal, always. Assert equals may boil down into equals if the default version of the equal is being invoked. However, in many cases, then in many of the cases, it will be invoking the overridden version. Yeah.
I was just wondering, why would we ever use assert same?
Well, I mean, assert the same is actually pretty, also pretty useful. Sometimes you might just want to know, am I talking about the same objects? And then after that, maybe if I'm talking about different objects, I mean different addresses, maybe I can then use the equals method. If I know that assert the same is already going to pass, I don't even bother with assert equals because the reference equality implies object equality, like what we just said, right? Yes?
What is the return type
Okay, that's a very good question. That one there, we don't really need to. Okay, the question was, what's the return type of this particular method here? The answer is it's a class called class. However, we don't really need to dive into that detail. I would say as far as the equals method is concerned, just understand this as like a dynamic type for the objects. That'll be enough. All right? All right, that's good. So we are done with this. We are done with that. And the next one will be to actually do a little bit more example that we can do that. Maybe let's take attendance and take a short break, and then we'll continue. I would suggest the following. For the next 10 minutes, I would like to review something that you maybe have learned in first year, but I think it's good to brush up. But I'm going to do the following. So for 1, 2, and 3, these 3 pages I'm going to assign as exercises between now and Thursday. I'm still going to go over the assertions on 1, 2, and 3 with you, but I'm going to go a little bit faster. So these are basically what we just said before the break. It might be nice for you to struggle a little bit with these exercises. Could be a nice practice question for written test number 2. Why don't we do that? And then for the next 10 minutes, I'm going to talk about short circuit evaluation. All right? I'm pretty sure you guys know about ampersand, and also vertical bar, vertical bar. But do you guys know what short circuit evaluation really is? Anybody? Okay, the best way to summarize it goes like this. In your logic course, have you guys heard about something called commutativity? Anybody heard about this term before? What does that mean? If I got P and Q, it should be equivalent to Q and P, right? Doesn't matter the order. Now, question for you. In Java, do we have commutative ampersand, ampersand? What do I mean? In Java, when I say P ampersand, ampersand Q, does it really equal to Q ampersand, ampersand P? Yes or no? Don't be shy. Yes?
Yes, because they both return Boolean.
Yes, because they return Boolean. Yeah, I agree, because they are both, in some way, in the math and in Java, they both return Boolean, yeah? However, the answer is no, they are not the same because of short circuit evaluation. So here, in Java, the way you put P and Q matters. All right, that's why we got to review that, all right? No in general. And let's see, all right? Okay, and I'm pretty sure you don't need to be bothered by the truth table for ampersand, ampersand, right? Okay, let's just remember one thing here. The only way you can get true for ampersand, ampersand is when both operands are true. If you got any of the operands or both of the operands being false, the result is going to be false. That's a very quick reminder of the truth table. So now, what does that mean? That means at a runtime, if I want to evaluate, let's say, P ampersand, ampersand Q. Now, here is a rule. Number one, Java is going to evaluate P first. No matter what. It doesn't care about Q just yet. And now there are 2 cases. If P evaluate to true, it would be corresponding to these 2 rows. If I know that P is already true, do I need to bother to know Q is true or false? I need to. Because if Q happens to be true, it can determine the result. If Q happens to be false, it can also determine the result, right? Then, evaluate.
Your attention, please.
Hopefully it's only testing. Okay, let's continue. If we got to evacuate, we evacuate, right? Okay, let's see. We might be fine. All right? Okay, that's 2.1. And for 2.2 over here, what if the P evaluate to false? According to the truth table, if I already know P evaluate to false, does it really matter if Q is true or false? Doesn't matter. The result is going to be false anyway. So now in this case, what Java will do at the runtime, if it knows that P is already false, it doesn't bother with Q. Skip. That's the critical difference. That's why I said to you guys, P and Q, Q and P are different. In some cases, you would rather evaluate P first rather than evaluating Q first. I'll give you an example. All right, in this case, we're going to skip. We're going to skip the evaluation of Q. All right, it's a very important idea to either know now or you already know. True or false, right? Okay. We got 4 more minutes. I would suggest, let me also talk about the vertical bar as well, and that'll be it. And you guys can review this a little bit, and we could go on to example on Thursday. What about vertical bar? Similar idea. Let's talk about it. The only way to make vertical bar or disjunction to be false is when both operands are actually false. That's the only way. All right, so now let's talk about it. So let's say you got P or Q here to evaluate. So now at the runtime, number one, you are going to evaluate P, no matter what. The evaluations always go from left to right, always. And number two, 2.1. If P evaluate to false, and in that case, it's really corresponding to this line here and this line here. If I know that P is already false, do I need to know what Q is? I need to. Because in that way, if Q happen to be false, the result will be false. If Q happen to be true, the result will be true. So I need to know. Okay? Then evaluate Q. You can see this one is symmetric. So here we'll talk about false. But for conjunction, it's actually true. Right? They're symmetric. Okay? Now 2.2. 2.2 over here. If P evaluate to true. And this will be corresponding to these two rows over here. If P is already true, it doesn't really matter what Q is. It will be true anyway. All right? Then skip. The evaluation of Q. All right, so these are the two very important results you want to make sure you know before Thursday. All right, any question? Okay, and I got 2 minutes, but that's okay. Let me just give you more here. I'm going to also give you this page over here and this page here, and think about this example here, which we're going to go through. All right, thank you so much. I'll see you on Thursday.